Hello and welcome all on Unacademy JEE English, a channel launched by Unacademy where each and every topic of JEE will be covered in pure English. Right? So I'm Rahul Kaushik and today I will take lecture number 11 for Chemical Kinetics, and it is also the last lecture for this topic. We have already covered 10 lectures, but before I start today, let me tell you something about myself. I'm Rahul Kaushik. I was head of department Bansa classes Kota. I worked there since 2010 to 2020, and I mentored 2000 plus IITians there, 2000 plus guys. And after that, I co-founded my own organization, Zigyan Education Private Limited, and now I'm here on Unacademy, India's largest and fastest growing online platform, and I'm ready to share my experience and knowledge with you guys. Right? I hope you got my point. Now, how you people can be the part of Unacademy, how you can subscribe Unacademy learning app. You have to just follow some simple steps. First, move to Play Store or App Store and just download Unacademy learning app. This one. Once you download it, install it. After installing, you will be directed to a page where you have to click on the plus. So once you click on the plus, you will get these programs for IIT JEE NEET, and you have to check for IIT JEE. Right? Now, just click on the get subscription. After clicking on this, guys, here are the options. There are different packages. For 1 month subscription, you have to pay 6,000 rupees. For 3 months, you have to pay 5,000 rupees. For 6 months, you have to pay 4,000 rupees. And for 12 months, you have to pay 2,500 per month. So let me tell you, right now I'm teaching for 2021. So this package would be best for you guys. And you just have to pay 2,500 rupees. Just 2,500 rupees per month. And what you are going to get after paying this? You are going to get access to not just my lecture and content. You are going to get access to the content of all senior most faculties across India. Now all senior most faculties are on an academic learning platform, right? And you are going to get all access to their content and everything, video lectures, content, where in case of 12 there will be continuous one-to-one sessions will also be there will be tests and all those things, right? So over and above, if you apply my code RahulCam, then you will be getting flat 10% discount. Actually, this discount is written for 2-year program, so you will be getting flat 10% discount. So that's about how you can subscribe to Unacademy learning app, right? So shall we start today? Chemical Kinetics lecture number 11. So till lecture number 10, what we have covered in last class, we did collision theory, and after that temperature coefficient and all those things, right? So today we are going to study what is molecularity and how does it help, what is mechanism, and how do we determine mechanism, or using mechanism how do we determine rate of reaction, or we are going to study all these things. Hello, hi Priyanka. Hello everyone. Yes. So now let's start today's lecture with a question, and the question is on your screen. Why on increasing temperature by 10 Kelvin rate of reaction becomes double or more than that? Actually, why this question? Let me tell you, last time we did temperature coefficient, and what was that? Rate constant at T Kelvin and rate constant at T plus 10 Kelvin. This ratio was between 2 to 3. This ratio was between 2 to 3. Hi Pavan. Hello. So last time we did it. So in recap, I am giving you this question and waiting for your answer. Why on increasing temperature by 10 degrees Celsius, rate of reaction increases by, it becomes double or more than that? And you people know temperature coefficient was 2 to 3. So tell me any answers. K is equal to A e raised to the power minus EA by RT. E raised to the power minus EA by RT. So I told you this A is almost independent of temperature. So on increasing temperature, K increases. It means if it is almost constant, then why this K is increasing? This K might have been increasing due to this. And what is this whole term? What is this whole term? This whole term is called fraction of molecules. Fraction of molecules having sufficient energy for conversion into product. So what is that? It is basically fraction of molecules having sufficient energy for conversion. Means when you are increasing temperature by 10 degrees Celsius or 10 Kelvin, your K is becoming double and it is constant, almost constant. So it is getting double because of this only. It means on increasing temperature, this fraction of molecule having sufficient energy increases. And how will it increase? Let me tell you. Suppose here I draw dN upon N, this is fraction, 1 upon dE, this is kinetic energy, and it is E. So if we plot this temperature T1, this is at T. So if we increase temperature, then the plot will be like this. Right? So initially, if it was the threshold energy, suppose this was the EA, suppose 50. So this area, what this area was giving? This area was giving the fraction of molecules having sufficient energy, or fraction of molecule having energy greater than or equal to 50 kilojoule or this, right? So now when you have increased the temperature, now if you calculate this area almost become doubles. So we can say fraction of molecule having sufficient energy for conversion into product becomes double. That's why on increasing temperature, rate of reaction becomes double or more than that. This question has been asked many times in JEE Mains, so you must know the answer. I hope now you people got it. Hi Monica. So let's move to the next point. What is mechanism of reaction? What do you mean by mechanism? So in organic chemistry, you people have already studied certain mechanism. So what we do in mechanism? Now suppose there is a reaction A giving you product. So this reactant is getting into product, but conversion of this reactant into product is not a one-step process. Many a times it make intermediate compound, many a times it makes some activated complex or anything like that. So this conversion of A to P, it might take 2 steps, 3 steps. So we will break this reaction into those steps in which it take place, right? Hi Vignesh, hi Karthi. So A, suppose step 1, A was giving me something A star. In step 2, it was A star plus B. Suppose B was some catalyst. So it was AB. It is now intermediate. Right. Now this AB is giving me P, product. So what I'm saying is I have divided this reaction into 3 parts, and each part is called one step. So this is called mechanism. So what is mechanism? So mechanism is basically, it represents the path through which a reactant is getting converted into product. So each step will be an elementary reaction. So I told you each step will be elementary reaction, and this whole will be complex. So any reaction which consists of more than 2 elementary reactions is called complex. And it is very important topic for JEE Mains point of view also, molecularity. So now you know the mechanism. So in mechanism, we distribute or we cut down the reaction into 2 or 3 parts, and then we find out how reactants are getting converted into product. I hope you got it. So now next, what is molecularity? Next point, anybody, what is molecularity? Please tell me. So molecularity, the number of reacting species. Now reacting species can be atoms, those can be molecules, or those can be ions taking part in an elementary reaction, which must collide simultaneously in order to bring about a chemical reaction is called molecularity. That's very important point here. Number of reacting species taking part in an elementary reaction. It means one thing is clear. Molecularity is defined only for elementary reaction. Molecularity is defined only for elementary reaction. I hope you got this point. Hi Priya. So number of reacting species, those can be atoms, molecules, or ions, that are taking part in elementary reaction which must collide simultaneously in order to bring about a chemical change is called molecularity. So now what is this simultaneously? Now what is this simultaneously? Tell me. Suppose two molecules are colliding. Now let me write A plus B. These are giving product. So A plus B are giving you product. So A and B, suppose you have taken them in a container. This is A, and let me take some different color for B. This is B. So now A and B are combining, and on combination they are giving you products. So what will happen? In order to form product, at least A and B has to come close to each other, and when they will come close to each other, they will basically collide. So if two particles or two objects are colliding, that will always be simultaneous. So the simultaneous collision of three, what does it mean? It means when these two are colliding at the same time, their third one comes. Like you can take, if these are three fingers, when these two fingers are colliding at the same time, third should collide. That is called simultaneous collision. So it is very difficult that when these two are combining at the same time, third comes, right? So combination of three at a time is very difficult. As a result, the reactions having molecularity 3 are rare. There are very few, and more than 3 molecularity, suppose we take 4, so collision of 4 molecule and simultaneous collision of 4 molecule is very difficult, almost negligible. Till today we have found no reaction having molecularity 4. So now you know the answer. Hi Ananda. So number of reacting species, it can be atoms, it can be ions or molecules taking part in an elementary reaction which must collide simultaneously in order to bring about a chemical change is called molecularity, right? So now let's move to the next point. Types of molecularity. How many types of molecularity are there? So there is a unimolecular. Uni means one. So now students generally ask questions, sir, if there is one molecule, then how will it collide? So in that case we say, if there is one molecule, so basically there will be dissociation, and when you heat it, it will start vibrating, and we consider it, and after vibration it will start. Suppose we have taken NH4NO2, it will break into this and this. So we call it unimolecular reaction. Actually exactly in this case, exactly collisions are not taking place. So basically when you are heating for unimolecular, you will be having only one reactant, and one reactant is there, then we call it dissociation. In that case, when you increase temperature, then the molecule will start first vibrating, and if you increase its temperature more, its energy will increase and it will break down, and then some new molecules are formed. So it is called unimolecular. So now what is bimolecular? Now bi, name suggests two. So these are the reactions involving collision between two species. For example, hydrogen and iodide. I have written this. So two Hi molecules are colliding to give you H2 gas plus I2 gas. So now these two are colliding. We call it bimolecular reaction. I hope you got my point. Yes, Ananda, Vignesh, Priya, Monica, Pavan, any doubt? So now you understand unimolecular, you understand bimolecular. In every case, reaction must be elementary because molecularity is defined only for elementary reaction. I just told you. Now, trimolecular. What is trimolecular? Name suggests there will be three molecules colliding simultaneously, and only then product formation will take place. Right? So, trimolecular or termolecular reaction involves simultaneous collision between three reacting species. So we can take this example: 2NO plus O2 giving you 2NO2. I hope you got it, Pavan, Ananda, Priya, Karti, Vignesh. Got it? So unimolecular, bimolecular, trimolecular, and there is one more point: rate determining step. What is rate determining step? Yes, rate determining step. What is that? Tell me. Do you have any idea about it? Okay, we will discuss it. Rate determining step. What is that? We will discuss it in detail, but let me tell you. Now suppose it was reaction A giving you product, and this reaction was taking place in three steps: step 1, step 2, step 3. And suppose this step is slowest, because all three steps will not have same rate. One step might be faster than the other, so there must be some step which should be slowest. That slowest step is called RDS, rate determining step. It is similar to chemistry. Chemistry is also RDS, rank determining subject. Because if you have very good chemistry, then you can get a very good score. In chemistry, except physical, inorganic, there are many things which are information based. If you know them, just click them, and 1 minute you can get 4 marks within 1 minute or 30 seconds. But you can't get 4 marks in 1 minute or 30 seconds in physics or mathematics. In mathematics or physics, you have to solve problems, and those problems can be time consuming. But in chemistry, yes, you can do it. So RDS, if a reaction takes place in more than one step, then the slowest step is called RDS, rate determining step. We can take one simple example. And what is that example? Okay, let me take it. Suppose there is a cycle company. There is a cycle company. Now it is very easy to understand. And this cycle, how many tires are there in a cycle? 2. This company is making 100 tires per day. This company is making 50 seats. This company is making 500 tubes. But this company is making 10 chains. Chain. I hope you know the chain, how chain is placed in a bicycle. Right. So my question is, at the end of the day, how many complete bicycles you are going to get at the end of the day? This is the production in a day: 100 tires, 50 seats. So one seat is required for one bicycle, and 50 and 500 tubes. Okay, so how many? 10. Pawan says 10. So 10 cycles I'm going to get at the end of the day, complete cycles. Yes. So how many cycles will be formed actually depends upon the slowest step, not the fastest. Right? Similarly, at what rate a chemical reaction will occur, that rate will be determined or will be equal to what? Rate of slowest step. And reaction cannot exceed the rate of slowest step, and that step is called rate determining step. I hope you got my point. So let's move to the next point. Now unimolecular, bimolecular are done. Some important point about molecularity. So when I'm saying molecularity, A and B two molecules are combining and these are giving me product. So molecularity will always be an integer, a positive integer, because there cannot be a collision in which half A collide with complete B. It can never be fractional and negative has no meaning. So by definition, if we go, then molecularity can never be zero, it can never be fractional, and it can never be negative. It will always be a positive integer, because either two molecule will combine or three will combine, but one and half will never combine. It how will I say like half of A is combining with B? That is not possible. If A and B are combining, then those will be complete, right? The probability that more than three molecule can collide and react simultaneously is very small. Hence the molecularity greater than 3 is not observed. I discussed this point because collision of three molecules, simultaneous collision of three molecules is very difficult. As a result, the reactions having molecularity 3 or more are rarely found. Next point. Order of reaction is an experimental quantity. It can be, order of reaction can be 0, it can be positive, negative or fractional, but molecularity will always be a positive integer. Now you know it. And I told you, what about half O2? No, we will never write half O2. If we are determining molecularity, suppose you are writing this H2 gas plus half O2 gas. It is giving you H2O liquid. So I will never write this way. When we are talking about molecularity, then if it is elementary, if it is, I don't know whether it is or it is not, because you asked for half O2, that's why I'm writing it. Now this, you have to write it in pure integral form. Never write that way. In case of molecularity, in mole concept you can do. In mole concept, Pawan, you can do. Yes. So the order of reaction is an experimental quantity. It is done. The order is defined for elementary as well as complex reaction, and you know this. We can determine order for elementary as well as for complex, but molecularity is defined only for elementary reaction. For complex reaction, molecularity has no meaning. How? Why it has no meaning? So let me take it. If a reactant getting converted into product, suppose this reaction take place in 3 steps. Step 1, reactant to R star. Step 2, R1 star. Step 3, now it is product. So this reaction is taking place in 3 steps and each step is elementary. So you can define molecularity for each step. Now here if I take B as catalyst and I write like this way, so molecularity here will be 2, molecularity here will be 1 and molecularity here will be 1. So I can define molecularity for each step. But if someone asks me what is the overall molecularity, so there is no term like overall molecularity. There is no term like overall molecularity. Right? Any doubt? So there is no term like overall molecularity. Any doubt? So here I can say molecularity is defined only for elementary. However, order can be defined for what? Elementary as well as for complex reaction. Now it's clear. Let's move. For an elementary reaction, order and molecularity are same. Let's see how. Suppose I'm saying this is an elementary reaction. So how will you write rate law? You will write rate law as K into A raised to the power 2 into B. This is rate law. So order will be 2 plus 1, that is 3. And if it is elementary, then its molecularity will also be 3. So a molecular elementary reaction will have same molecularity as well as same order. I hope you got my point. Now let's move to the next point. Let's take some cases how we people determine mechanism. So how do we do this? Case 1, if reactants are directly converted into product by simple reaction. Suppose I take simple reaction A plus B giving you products, right? And I told you that it is elementary reaction. It says simple. Simple means elementary. Now how will I write rate of reaction? What will be the order of reaction? Just write down the rate law expression. Please tell me. Yes, Pavan. Yes, Nathi Chandrasekhar. No, we will take parallel and reversible in special class, because about reversible no question has been asked in last 20 years. So we are not going to take that. Even on parallel. Yes. The reactants are directly converted into product. Just write down the rate law expression for it. Rate law expression. Right. That is done. So if you are given an elementary reaction, you can easily determine its order. Let's take one real example over it. NO gas plus O3 gas giving you NO2 gas plus O2 gas, right? So I told you that it is elementary. Then write down the rate law expression. Tell me. Write down the rate law expression. Hi Sabaris. Yes, Nathi, solve it. Sabaris, Pavan, for education, everyone, solve it. I'm waiting for your answer. So K will be NO and O3. Right. Ozone. Good afternoon. So how are you people? So are you enjoying this chemical kinetics? Because tomorrow onward I'm going to start liquid solution. Hi Dia, yes, you are right. Tomorrow onward I will start liquid solution. So let's move to the case number 2. If a reaction takes place in more than one step, yes, steady state will come definitely. In case 3 it will come. Don't worry Nati, I will discuss it with you. If a reaction is taking place in more than one step and one of them is slow, now what will happen? Now there is a reaction. Let me take A plus B giving you P. So this is the reaction and these are the steps. Step 1, step 2. So I have already told you there is one fast, one slow. So tell me, what will be the order? I just discussed a point with you guys, and what was that point? That point was, if a reaction takes place in more than one step, then those steps will have different rates. Then rate of reaction will be equal to, what? The rate of slowest step of the reaction. So now I will write, this is slowest, so I will write rate is equal to K into A into B. And you have to keep one thing in mind here, this I star, this is intermediate. So what are intermediates? Intermediate, these are the species which are produced during reaction and get exhausted during reaction. So you will not find intermediate before and after reaction. They are produced during reaction and they are finished during the reaction. Like, so in rate law expression, you have to keep in mind always reactant and product should appear. Except reactant and product, nothing should appear. Because by this way I can say, if I double the concentration of B, rate of reaction will double. If I double the concentration of A, rate of reaction will double. If I increase the rate of concentration of A and B by twice, I do it twice for both, then rate of reaction will become. I will never take intermediate in rate law, because intermediate is something that is beyond our control. I cannot say I'm taking concentration of intermediate double. Never it will be like never. So if intermediate or anything other than reactant and product appear, then you have to eliminate that thing. Right? So somebody said catalyst. No, catalyst has no role here. Catalyst has no role. No, this is simply an intermediate. So let me take one real example and you people can write it. 2NO2 gas plus F2 gas. Just solve it quickly. So step 1. Slow. Fast. Right? So this is K1, this is K2. Write down the expression for rate law. Quick. Next chapter will be liquid solutions. Yes, Savaris. Liquid solution, Henry's law, colligative properties, azeotropic mixture, and ideal solution, non-ideal solution, fractional distillation. So many interesting things are going to come. Yes. This is slow, this is fast. So in question you will be asked to write rate law expression. Yes, I'm waiting. Just write it down. Tell me the answer. In mains, such type of question are asked. Yes, definitely on Sunday we will take a quiz on chemical kinetic. Don't worry. Sunday, quiz day. Right? So now this is slowest step. So rate will be K1 into NO2 into F2. It is done now. Right? So let's move to the next case, and that case is this one. Here, if I'm taking a reaction A plus B giving me P, this is reaction and it takes place in two steps, step 1 and step 2. And one of the step is reversible. Before this case, there was no case of reversible. Now, how will I solve it? Yes, tell me. Now, how will I solve it? Tell me, guys. Thank you, Savaris. But nobody gave me such a good compliment. I don't know whether I look like Salman or what hero. I'm simply a teacher. Anyways, thank you for your comment. I hope you get best out of me, maximum out of me, and you can get a good rank in IIT JEE Mains and Advanced. Hope to see you all people in IIT JEE next year. I think you are preparing for 2021. Okay. So solve it. Now this reaction is given. A plus B giving you product. In step 1, you have A plus B giving you some intermediate, and that step is reversible and that is also fast. Now in step 2, that step 2 is slow. So now find the rate law expression. How will I do? Again, every time I will start with slow. So what it will be? So rate will be minus dA by dt minus dB by dt, dP by dt, and dp by dt I can say it is rate. I hope you are getting my point, because I will always start my reaction with the slowest part. Where to start? The first point that comes to your mind, sir, from where, from which part of question I should start solving? So always look for slowest step. Always look for slowest step. Thank you, Pawan. But I think we should focus on studies. Yes. Thank you for your compliment. Solve it. I would be more than happy if you people solve it. Definitely, I'm going on a special, and there I will run a special series for JEE Mains and Advanced. Right? Definitely, I'm going to take. Actually, there are some technical issues, so there will be definitely a series. You might check. I have already taken a quiz on chemical kinetics on this Sunday, so you can go through that. Okay, Nati? Yes, definitely. So this dp by dt, I can say basically this is rate of reaction, and if somehow I calculate value of dp by dt, then I will be able to find the rate of reaction. So from second part I can say dp by dt is equal to k2 into I star. But the problem is, I told you this is intermediate, and I just told you intermediate should not be there in rate law expression, so you have to eliminate intermediate. So what will you do? Tell me, how will you remove this intermediate? Let's take two more constants. This is k1 and this is k minus 1. Okay, let me change color of this. K1, k minus 1. So k equilibrium will be equal to k1, k minus 1, and it will be equal to I star over A and B. And I want to remove this I star. Why? Because it is intermediate, and intermediate should never appear in what? Rate law expression. Now how will I do it? Solve it, just try it. So Nati, for your information, daily after the class I am taking a short quiz of 5 questions every day, in which we are taking JEE Mains as well as advanced questions daily. Every class, you can see the previous lectures. In every class we do this. So now instead of I star, you can place here k2 into k1, k minus 1 into A into B. So this dp upon dt will be equal to k1 k2 upon k minus 1. So this whole is constant, so I say k overall. So order of reaction will be 2. Yes, Pavan did it right. Pavan did it right. Yes, Pavan, you are right. So now let's move to the next point, and here comes the important concept. Actually, k overall. What is this k overall? What is this k overall? Let me tell you. K1 k2 upon k minus 1. So what is that? K1 I will write a1 e raised to the power minus e1 by rt. K2 a2 e raised to the power minus e2 by rt upon a3 e minus 1 by rt. So on solving this I will get a1 a2 upon a3 e raised to the power e1 e2 minus e minus 1 by rt. So this is overall activation energy. Very important point is going to come, students. Very important. Just read it carefully. Be careful about this point. This is called E overall. And E overall can be positive, negative, or zero, or fractional. You can say actually E overall activation energy for reaction depend upon the magnitude of E1, E2 and E minus 1. So it can be negative. Generally, I told you for elementary reactions, activation energy generally positive for complete reaction, for complete elementary, not part of this. So in this case, I will write K overall is equal to A overall into e raised to the power minus E overall by RT. So this E overall can be positive, negative, or zero. So I can say if a reaction is complex, its rate of reaction may increase or decrease on increasing temperature. Because if it is positive, then on increasing temperature, rate of reaction will increase. We have already done this thing in last to last lecture. So just note down this point, very important point for IIT JEE Advanced. Very important point. For complex reaction, rate of reaction may increase or decrease. Just note down. If you are studying it without copy and pen, you are wasting your time. For complex reaction, rate of reaction may increase or decrease with increase in temperature. Why? Because activation energy can be positive or negative or zero. So it might remain unaffected if it is zero. This point was discussed. So activation energy can be positive or negative for complex, not for elementary. Right, Pavan? Yes. I hope you got this point. Got it? Any doubt? Any doubt? No doubt? So let's take a real problem over it. Solve it. Question is 2NO gas plus O2 gas giving you 2NO2 gas. Solve it, everyone. Step 1. Step 1 will be 2NO giving you N2O2. This is K1, this is K minus 1, and this is fast. Now step 2 is there. N2O2 plus O2 gas giving you K2, and it is equal to 2NO2. And this step is slow. Now solve it. Determine its rate law expression. I am waiting for your reply. Yes, Pavan, Karthi, solve it. Tabaris, everyone, just solve it quickly. You can do it. Start it. Now what it will be? Please tell me. So this is fast, this is slow. I will again start with it. So ROR will be 1 by 2 d NO by dt. It will be minus dO2 by dt. It will be 1 by 2 d. And I am going to get K into something. So this is basically ROR. So this is intermediate. So I will write ROR is equal to 1 by 2 dNO2 by dt. It will be equal to K2 into N2O2 and O2. Now there is one problem. This O2 is okay because it is part of reaction. But what is this? In whole reaction, there is no N2O2. In whole reaction, there is no N2O2. Now, what should I do? So I have to eliminate this N2O2. I have to eliminate this N2O2. And how will I eliminate this N2O2? Now again I will use the equilibrium concept. K equilibrium will be equal to K1 upon K minus 1. is equal to product upon NO square. So just put it here. So ROR will be K2 NO square into O2. So this is K overall, and it will give you, right? If you have any doubt, please ask. So now you are clear with it? Yes? Any doubt? So overall order will be 3. Now case number 4, very important. The steady state concept is going to come over here. Here I will get A plus B giving me P. So this is reaction. Yes, Pawan, you are right. This is step 1. This is step 2. Yes. Now solve it. Yes. Solve it. Moving with comparable rate, actually just remove it. In this case, you will not be given slow or fast. Actually, that was copied from the last one, so remove slow and fast. Problem will be like that. Now, what will you do? No and slow and fast step is given. Till this question, what we were doing? Tell me. We were taking, every time we were taking slow step and starting our reaction from there. And once we are taking the slowest step, from there we were removing intermediate. But in this problem, we don't know which step is slow and which is fast. And it says both are comparable. Means rate of first step is comparable, almost equal to rate of second step. Now what will happen? Now you people don't know how to start. This is K1 and this is K minus 1. Now how will I start this? No slow step is given, Pavan. No slow step is given. Yes, tell me. So what I can do is, again, dp by dt, I know ROR will be equal to dp by dt. And now this dp by dt will be equal to K2 into I star. And now I know this I star is intermediate and it should not appear in rate law expression. I have to eliminate it. Now what will I do? Actually both are comparable, means rate of first reaction for second is comparable, means I can say the rate at which I is appearing, at the same rate it is disappearing. This is called steady state. Steady state. What is a steady state? Note it down. When rate of intermediate formation is equal to its disappearance, or amount of intermediate is very low, we call it steady state. Very important, note it down. What is a steady state? So when intermediate, rate of appearance of intermediate becomes equal to its disappearance, we call it is a steady state. Or at a steady state only small amount of reactant will be there. So I can write di by dt is equal to 0. So rate of formation of I is equal to rate of disappearance of I. So let's decide from where intermediate is getting formed, in which step it is being formed. So it is forming from first step and it is disappearing here and here backward. Just see, there are two ways I star can disappear, but it can appear only on one way. So rate of appearance will be K1 into A into B. Now rate of disappearance, first it is going reverse, K minus 1 into I star, and then it is going here minus K2 into I star. Now we can get I star here. I star will be K1 into A into B over K minus 1 plus K2. And now I can place this I star here because now I have A and B, and A and B both are reactants, and A and B both are reactants, right? A and B both are reactants. So once I put it here, then I'm going to get K2, K1, K2 plus K minus 1 into A into B. So again, overall order will be 2. So this is called steady state, guys. This is called steady state. Any doubt? Pavan, Karthi, any doubt? Nati, Diya, no doubt? Now if K2 is very greater than K minus 1, then what does it mean? It means this become fast as compared to first one. Now what will happen? Ignore K minus 1 and I will get ROR is equal to K1 into A into B, because K2 will then cancel out. K2 will then cancel out. Any doubt? No. Actually, when I am making a reversible reaction, for forward I am taking K1, for backward I am taking K minus 1. So these are not equal. Pavan, these are not equal. Right? Just let me know. Yes. Any doubt? Any doubt? No doubt? So this case is already done. Now the next case, photochemical reactions. So the point arises, what are photochemical reactions? Can you guys tell me photochemical reactions? Then we will take a problem. So first of it, let me take one example. H2 gas. Okay. Photochemical reaction. H2 gas plus Cl2 gas will give you 2HCl gas, and here we write H nu. It is basically photons. So what is photochemical reaction? Actually, in photochemical reaction, homolytic cleavage take place. This sunlight, or when these photons strike, then this chlorine gas molecule will dissociate into chlorine free radicals. Now what will happen? This free radical is very unstable, and how many free radicals are formed? It depends upon the intensity of light, how many number of photons are striking with this. So chlorine molecule is being dissociated. Now what will happen? Now this Cl radical may combine with H2 and it will give you HCl plus H dot. Now this H dot may combine with Cl2, it will give you HCl gas plus Cl dot. Now anything can happen, it can keep on going. So this is basically called chain initiation step, and these are basically called chain propagation step. I hope you got it. And after this, if Cl dot combine and gives Cl2, this reaction may also happen. And if this reaction happens, we call it chain terminating. So these are terminologies used for a photochemical reaction. First we have chain initiation, then we have chain propagation, and then we have chain termination. So now this is chain initiation step. It will always be, the first step will always be zero order. It will not depend upon the concentration of chlorine. It will depend upon intensity of photons which are colliding chlorine molecules and breaking it. Right? Yes. So it is good if you have already learned it. Then let's move. So now first step of photochemical reaction is zero order, and its rate depend upon intensity of photon. And overall order of photochemical reaction can be zero or can be non-zero. Just note it down. Overall order of photochemical reaction can be anything. Why I'm saying this anything means most of the time people think all photochemical reactions are zero order. No, it's wrong. It can be fractional, it can be 1, it can be negative, it can be anything like a normal order. And photochemical reactions are always exothermic, complex. There will be no photochemical reaction that take place in single step. These will always be complex. I hope you got my point. So now we can start this problem, and the problem is on your screen. Solve it. So the reaction is, find out this. So this is H nu, basically first step of photochemical reaction. So what is this? Actually the reaction is C12H14 giving you C24H28. Yes, this is step 1, this is step 2. Now solve it. Let's see who solved it. It is a bit difficult problem. Yes, solve it. It's a bit difficult. I'm waiting for your answers. Yes. So we can take it K2. Here we can take it K1 and K minus 1. Okay, Pawan. Let's see. Now how will I write? This is the product. Will be equal to K2 into C12 H14 C12 H14 star. And now the problem arises because an intermediate is appearing into it. Now what will happen? We have to eliminate it. Now how will I eliminate? From the above. So applying steady state on it. So I will write D over dt is equal to 0. So its formation rate, most of the student will write like this way, H14. Now disappearance rate will be K2 and minus K minus 1, because it is being disappeared by two ways. One is this, another is this. So it is being disappeared. And here I will also write, no, there is a mistake. Here I will write K minus 1 into C12H14 star, right? And minus K2 is equal to C12H4 star and C12H14. Yes. When you people are writing this, it is again wrong. There is an error. This forward step, this forward step is first step of photochemical reaction. It will be zero order. So for forward, when I'm taking K1 into this, it is wrong. I have to just write here K1 into intensity of photons. Into intensity of photons. Now you will be able to solve it. Now you can write K1 into I means intensity of photon, K minus 1 into C12H14 star plus K2 into C12H14 star, C12H14. Now take K minus 1, K2, C12H14. Now K1 into I. Now what is this? C12H14 star will be equal to K1 into I. I is basically intensity, don't take it in square brackets, upon K minus 1, K2 into C12H14. Now put this value here and you are done. So I will get rate is equal to K1 K2 upon K minus 1 plus K2 into C12H14. Now my intermediate is eliminated, C12H14. I think this is done now. Please tell me. I think this is done now. The most common error is done here. You have to be careful about it because I just told you now this is first step of photochemical and it will be the first step will be zero order. You have to keep in mind, right? So now it's time for quiz. We have covered the whole concept. The whole topic is now over. So let's move to the quiz. Yes guys, question number 1 is on your screen. Just answer it. Solve it. Fractional order must be complex reaction. Just tell me. Yes, I'm waiting for your answer. Quick, quick. It's very easy. Any answers? Yes. No, how can we cancel? We can't cancel actually. It's like this whole expression. It is not independent. We can't cancel. So just solve it. Solve it. 30-second question it is. Just 30-second question. Yes. The fractional order reaction must be complex. It is true. Because fractional order, if I write half A giving you B, and if it is elementary, then its rate law will be K into A raised to the power 1 by 2. And its molecularity will also be half. And that cannot be half. I just told you molecularity will always be integer. So it is true. Fractional order of RDS equal to overall order of complex reaction. No, it's wrong. You just determine so many rate law expressions. So it is not necessary. So first is true, second is C. Nobody did the right answer. So let's move to the next question. Now solve it. If I is the intensity of absorbed light and C is the concentration of AB, the problem I just discussed 5 minutes back, then AB plus giving you this, then rate of formation of AB star is directly proportional. So it is again showing H nu, means it will be first step. So it is independent of concentration of A, right? So its rate will depend on K into I, intensity, K into I. I hope you got it. So it is B. Yes, Pawan, you are right. You are right. So let's move to the next point. Question number 3 on your screen. Solve it. Higher orders, it means order greater than 3, are rare. Why these are rare? This point was also discussed in today's class. Yes, tell me. Pavan says C. Because of low probability, because if number of molecules or reacting species are very high, then chances will be very low for collision. Because I told you, if collision of two objects are taking place, it will always be simultaneous, because when this object is colliding, same it will also collide at the same moment. But simultaneous collision of three is very difficult. So when these two are going to collide at the same moment, this third one should collide. That's difficult. That's why the probability of simultaneous collision for 3 and more become very low. So you got the right answer. Now let's move to the next question. Statement 1. Logarithm of temperature coefficient of one step reaction may be negative. The rate of reaction having negative order with respect to reactant decreases with the increase in concentration. So just solve it. Yes, solve it. So temperature coefficient will be upon K, and we get it as EA upon R T1 T2. This is temperature coefficient. This is T2 minus T1 will be 10 EA upon R. So if we write logarithm of nu, it will be log of 10 EA by R. So now again read it. What it says, logarithm of temperature coefficient of one step. Now if process is one step, it means EA will be positive. If process is one step, EA will be positive. Yes or no? Tell me. Okay, actually it is logarithm of this. I have committed a small error. ln this. It will be. So EA will always be positive. And if it is positive, so what will happen? Logarithm of temperature coefficient of one step. Yes, answer me. What will happen? So how will I write? So ln nu is equal to 10 EA upon T1 T2. Tell me. So it will always be positive, and it says it is negative. So it's wrong. It will always be positive. Why? You can see it. Purely mathematical problem. Log is defined, but we don't have to take log. I hope you got it. So the next problem on your screen, for the first order reaction, A giving you B plus C, carried out at 27 degrees centigrade. If this much percentage of the reactant molecule exists in activated state, then EA of the reaction is. Now tell me. So this is the percentage, and this is the percentage of molecules which exist in activated state, and I know the fraction. So fraction of molecule in activated state is minus EA by RT. So what will be the percentage? It will be 100 into E raised to the power minus EA by RT. It will be 100 into E raised to the power minus EA by RT. Right. So you just have to write 100 E raised to the power minus EA by RT is equal to. Now you will get the answer. So it was just for information. Right. Right. So guys, this was all about. Now this topic is over. Now this topic is over. Yes, this topic is over. So if you really like this topic, then guys, don't forget to like and share. Don't forget to like and share it. It's very important. And click on the bell icon so that you guys can get latest notification for our lectures, right? And how you can subscribe to Unacademy Learning app. Just let me tell you briefly. Go to App Store or Play Store, download it, install it. After installing, click on the plus. When you click on the plus, click on IIT JEE course because we are preparing for that, and then click on the get subscription. Once you click on that, you will be directed to a page where different payment options will be given. So right now we are doing it for 2021. So guys, this will be best for you. And I just told you, once you buy this subscription pack, you are going to get access to not just my content, but the content of all senior most faculties who are working on Unacademy learning platform. They are contributing each day, each and every day they are contributing vast resources. So you are going to get access to all that, and you are just paying 2500 rupees per month. And after this, if you apply my code RahulChem, then you are definitely going to get a flat 10% discount because this data is for 11th. So you can apply this code RahulChem. If you apply this code, you will be getting this, right? And from next class onward, from tomorrow onward, I am going to start liquid solutions, 12th class topic. That's very interesting and easy topic. And in that topic, we will discuss many things like what is Raoult law, what is vapor pressure, what is azeotrope, and what is fractional distillation. What are colligative properties? Elevation in boiling point, depression in freezing point, all those things we are really going to do, because in azeotrope you people have so many doubts, and every time in advance a simple problem is asked from this topic liquid solution, one from this, right? Yes, Pawan. So definitely we will do it tomorrow, right? So till tomorrow, take care, tata, bye bye, and we will meet you. I will meet you tomorrow in the next session, the first lecture of liquid solution. Take care, bye.